Good morning. We're going to talk about another triangle thing today, triangles and the exterior angle theorem. It's very important that you know what these vocabulary words mean, so I want to make sure that we're all on the same page. Any angles that are inside a figure are called interior angles. All three of those are interior angles. Any angle outside is called an exterior angle. It's important to know that the exterior angles are formed by extending a side, like this, like I just did. That would be an exterior angle, okay? But it is also important to know that it is not formed like this, and I'm going to use a pencil so I can erase it. Don't draw this. You can't just go like this and make an exterior angle. It has to be an extension of a side, where you take the side and you just keep going, extend the side. This would be an exterior angle. We could draw it the other way also, this way. That would be an exterior angle. But just randomly putting a line like, boop, no, that's not an exterior angle. It has to be an extension. All right, and if we took a protractor, let me see if I have mine. I can demonstrate for you if I do. Oh man, I don't. If I had one, I could show you, actually, hold on one second. Okay, so if I measure this exterior angle, oops, I moved my thing. This exterior angle looks like it's about, let's see, maybe 100 degrees. Here, this example, not all of them. That means this is 80 degrees. If we measure this over here, that one is 60 degrees. And if I measure the one up here, that's 40 degrees. Okay, so I want to point out a couple things. First, there's a linear pair where the exterior angle and an interior angle meet. Okay, so that's how we can determine those. Here, these two angles actually have an even more specific name. They are called remote interior angles. And keep in mind that remote, like you use a remote control far away from a TV, or a remote location is far away. The remote interior angles are the farthest ones from the exterior angle. The one right next to it forms a linear pair. Okay, and what do you notice about that? 60 plus 40 equals 100. So the rule is that the exterior angle of a triangle is equal to the sum, that means add, of the remote interior angles. All right, so a little visual that might help you. This plus this equals this. Okay. All right, and it's in a box, so make sure that's visible when you glue this into your notebook, because this is obviously important. All right, we're going to do a couple examples, some easier, some not so easy. All right, so the first one. The sum of the remote interior angles is equal to the exterior angle. So angle 1, I'm going to change that to an x, because we don't know it. X plus 79 equals 104. So to find that other remote interior angle, we would do this. So x equals 25. All right, now that's really the end of the problem. But if you wanted to figure out this angle, there are now two ways to do it. You can either add these up and subtract from 180 using the triangle angle sum theorem, or you could notice that there is a linear pair right here and do 180 minus 104, which would be 76 degrees. Also, just look at this. It almost looks equilateral, or it's not equilateral, isosceles, but it's not, so don't assume that it is. All right, let's look at the next one. This one's kind of crazy. All right, it says to find the measure of all of these angles. Looking at angle 1, since it's over here, I'm just going to focus on this triangle, this brown triangle right here. How many degrees are in a triangle? 180 total. Okay, so to find angle 1, we could do 180 plus 90 plus, 180 equals 90 plus 43 plus, and I'll change that to an x for now, x. And actually, if I was doing this not as notes, I would probably just subtract it all in my calculator. 180 minus 90 minus 43. All right, so now we know that this is 47 degrees. To figure out angle 2, if you look at it, it's just an extension of this brown triangle. So this is an exterior angle. Exterior angles are equal to the sum of the remote interior angles. So if we add up 47 and 90, that would give us 137 degrees for angle 2. All right, and there's other ways we could do this, but I'm going to look at it like this now. We have another triangle. This one's scalene for sure. And the sum of the angles in a triangle are always 180 degrees. So we would do, to find angle 3, we could do 180 minus 137 minus 12. And that will give us 31 degrees. So angle 3 is 31 degrees. And because of how I wrote that, and I just feel like I wrote that a little bit weird, I also would like to point out that we have another triangle in this picture, this big one. And that also has to add up to 180 degrees. Okay? All right. So that's that. Pause and look at that a couple times if you need. It's kind of a weird one. And lastly, we have this one. This is the kind that tend to trip people up because they get used to this kind where they can figure it out using the linear pair. But this one, that's not going to be helpful. So we have our exterior angle here. And we know this angle and that angle. So remember that little visual from above? The remote interior angles add up to the exterior angle. So 5x minus 27 plus 7x minus 32 equals 9x minus 8. So 12x minus 59 equals 9x minus 8. And I'm just going to solve this. So you can pause, solve your equation, and come back and check. Okay, so x equals 17. If the question asks for x, then you're done. If it asks for the measure of these other angles, then you are not done and you need to plug it in. Often, it will give you this problem, but ask you for this angle. Okay, and there are a couple ways you can do it, but all of them require substituting your x back in. So 9 times 17 minus 8 is 145 degrees. 5 times 17 minus 27 is 58 degrees. And 7 times 17 minus 32 is 87 degrees. I'm going to use the linear pair to figure out the measure of this pink angle. Linear pair right there. So 180 minus 145 equals 35 degrees. If you wanted to, you could also do 180 minus